All right, let's take another quick look at another example. We've got the function x squared sine of x. We're interested in the area under this curve from 0 to 3. So if we look at the function, what we see is that it looks something like this. And so we're interested in this area right here. So if you try to do 1,000 partitions on this function, the program cannot actually handle it. I played around with this one, was able to go up to 500 with no problem, but 1,000 it wouldn't deal with. Not 100% sure why, but presumably outside the abilities of the program to do the calculations. So what I'm going to do is I'm just going to show you what we get. If you want to do a few lower values, again, just to practice, but if we go up to 1,000, what we end up with is 5.77476 for the left rectangular approximation. We get 5.77667 for the middle rectangular approximation, and we get 5.77857 for the right rectangular approximation. Again, notice that looking at the middle, this one appears to be a little bit lower. This one appears to be a little bit higher, but they are accurate to a couple decimals. If we just ignore rather than round, we get 5.77. So we can see them converging on that middle number. There is a way to calculate the exact area, and we won't worry about that for now, but to 12 decimal places, we get 5.776667, 52456. Far more than you actually probably wanted to know. But also notice that to 5 decimal places with rounding, that is in fact the middle rectangular approximation of the area under this curve. So it's a pretty accurate process. So one other thing I do want you to think about before we move along is if I've got an increasing curve, the question is left and right, left or right, which will be over and which will be under. And if I have a decreasing curve, left or right, which will be over and which will be under. And this is an important distinction. Obviously, the middles will generally be about accurate, but left and right change depending on whether you have an increasing curve or a decreasing curve. Okay, if you're in my class, go ahead and do exercise 11 out of the book, and we'll be back with another example in the next video. Thank you.